So again, your test is tomorrow on 3.4 to 3.6. So today I just plan on going through the review to make sure you guys got the right answers, and then also go through what is going to be on your test tomorrow, so that way you kind of have an idea. So here's my question. Do you want me to go through what's going to be on the test first, or do you want me to go through the review and reference the test at that time? Go through the review and reference the test at that time? Okay. So if I remember right, I think I had you guys, 17 through 35 odds. And the first one, number 17, says solve the equation by using the quadratic formula. So I have negative x squared plus 5x equals 2. So when you're using the quadratic formula, it's important that you make it equal to 0 first. So what would I have to do to make it equal to 0?
Minus.
If I subtract 2 over, I end up with negative x squared plus 5x minus 2 equals 0. Now the quadratic formula I'm going to write over here on the right hand side, just so that everybody has it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Then, as a reminder to you, it's kind of hard. Is that better? Can you guys see the top of that square root now? Barely? Now, as a reminder to you, it's ax squared plus bx plus c equals 0. That's where the spots are at. So, what number is in the b position for our problem? 5. So I have a negative 5 plus or minus the square root of 5 squared minus 4 times, what number is in the a position? Negative 1. Don't forget that that's that sign there. And then what's in the c position? Negative 2. All over 2 times negative 1. Okay. So again, all I did was, you told me what numbers to plug in for A, B, and C. I plugged them in, and now we have to simplify this up. Don't forget the order of operations. However, there are some things you can do before that. Like for instance, the negative with the 5 becomes a negative 5. So there's no need to worry about that just yet. Plus or minus the square root of. Now, when you're on the inside of the square root, you do the squared part first. What's 5 squared? 25. Good. And then you do the next part, and this is the important part that you don't mess it up. It's a negative 4 times a negative 1 times a negative 2. Negative times a negative times a negative would be a negative number, right? What is 4 times 1 times 2? Yeah. So then what is 25 minus 8?
17.
Right? And just so that you guys know, if you mess up that sign issue, you're going to have the wrong answer. So be careful. And on the bottom, what's 2 times negative 1? Negative 2. Now, to be honest, this is okay to have this. Now, in reality, some people don't like the negative on the bottom, so what they do is they divide everything by a negative 1. Now, what they do is they basically change all the signs. This still stays plus and minus, and here's where they get away with that, just so that you know, is if you take a positive divided by a negative, you get a negative, but then a negative divided by a negative would be a positive, so that's where the plus or minus is still going to be important. Now, the only thing I would do differently is if I could actually reduce the 17. Can I square root 17? No. So at this point, this problem is done. The problem says, again, the directions were solve the equation using the quadratic formula. This is like 3 and 4 on your test. I'm looking at the test right now, and 3 and 4 say solve the equation by using the quadratic formula. Number 19 has 3x squared minus 12x plus 13 equals 0. So we don't need to write the quadratic formula down again because it's the same problem, just different numbers. What number's in the B spot? Negative 12. Plus or minus the square root of negative 12 squared. Minus 4 times what number's in the A slot? And what's in the C? All over 2 times 3. Now, to simplify it, a negative with a negative become a positive 12 plus or minus the square root of. Now, this part is important to make sure you don't get it wrong, but when you take negative 12 times negative 12, you do not get a negative number. Negative 12 times negative 12 would be a positive answer for the first one when you square something like that. Anybody know what negative 12 times negative 12 is? 144. Good. And on the back part of that, you have negative 4 times 3 times 13. What do you get there? What's negative 4 times 3 times 13? Negative 156. Good. All over. What is 2 times 3? 6. Good. On the inside, what's 144 minus 156? Negative 12. Now, on this problem, I had quite a few people on Friday get this one wrong from here. They had this part beautifully, and then they screwed it up after this. And it all comes with the reducing. The 12 and the 6 that are like the 12 in the front and the 6 that are on the bottom, yes, they can reduce, but you have to do everything together. It's all for one mentality and one for all rather than just one part. So what needs to happen when you reduce it is you need to do this part first. You need to reduce that square root. That's the first thing you should do. Now, how do you deal with a negative square root? You take an I out. Good. So you have 12 plus or minus. You'll have an I for sure. Now, I'm going to show this to you again because it's been a little while since we've done this. When I break down the 12. Does 2 go into 12? Yeah. 6 times. Does 2 go into 6? Yeah. And 3 goes in there once. I got a pair of 2's that go outside. And the root 3 stays inside. Now to reduce the whole thing. What I want to do is I only want to reduce numbers that are on the outside. I cannot touch them if they're inside the house. The house is a safe house. So therefore they are not allowed to be messed with. So that's why we only deal with the outside numbers. What number can I divide 12, 2, and 6 all by? 2. What's 12 divided by 2? 6. What's 2 divided by 2? 1. And then on the bottom, 6 divided by 2 is 3. So again, I had a number of people ask me that question on Friday, and the biggest thing was right here, the part that I circled, that's the part that they got to that, and then they messed it up from there. You have to get the square root cleaned up first before you can reduce. Okay? Again, you have 2 problems that are going to ask you to do that. 3 and 4 on your test are just like these last 2 that we did. What do you think? Okay. Then number 21. Number 21 has x squared minus 2x minus 9 equals 0. Looks like the same problem that we've been doing, except for now it's asking you a different part. On 21 it says find the discriminant of the quadratic and describe the number and type of the solutions of the equation. Now I'm going to read you the directions for 1 and 2 on your test. Find the discriminant of the quadratic equation and describe the number and type of solutions of the equation. Numbers 1 and 2 are just like number 21. where I even give you space to work, and then I write the word discriminant and then a line to put it on, number and type, and a line for them to put it on so that you know. The discriminant formula, again, is d equals b squared minus 4ac. So when I'm asking you for the discriminant, I want to know the number. What number do you get when you plug all the pieces into your equation? Then remember, if that number is greater than 0, meaning it's positive, you will have two real solutions, which again, that tells you how many, the number, and what type they are, real. If that number is equal to 0, you'll have one real solution. Again, that tells you how many and what type it is. So if it's equal to 0, it will be one real solution. And also, don't forget what happens if the number is negative. It's two imaginaries. Again, that tells me how many and what type it is. So let's find the number. It has to be equal to 0, which it is. So then what number is in the B spot? -2 squared minus 4 times what number is in the A slot? And what's in the C? So what is -2 squared? 4. What's -4 times 1 times -9? And what is 4 plus 36? 40. That's the first part of the answer. 40 is the discriminant. Now, the second part of the answer is how many and which type it is. Well, if the number's positive, how many would you have and what type is it? Two real solutions. You have two questions that are going to ask you to do that. 1 and 2 are just like this. Is there any solving going on as far as the quadratic formula? No. All it says is just tell me what the discriminant is and how many in each of, or what's the type and number of solutions. So if you look at, real quick, here's the test. Like, I even give you the blanks for that. So that hopefully triggers in your memory, that's what I need, and you have two things. Okay? How are we doing so far? Not too bad? Okay? That's the front page of your test, just so you know. And 23. Has 2x squared minus 2 equals y, and -2x plus 2 equals y. And it says solve the system by using any method. Now, this particular thing, if you remember the methods that we talked about graphing method and we talked about the substitution method. We did not use the elimination method because it doesn't work for all of them, but the other two do. Now, on your test tomorrow, there are two questions that are like this, one of each. Number 5 says you solve the system of equations by graphing, and number 6 says solve the system of equations by substitution. So with these next two problems, I'm going to do one of each, just so that you have seen both of them. Now, with this one being both y's, I'm going to graph this one. Does that make sense? And just so that you guys know, when I gave you the problem like that on your test tomorrow, they're already set up for you as y equals. So you don't even have to do anything as far as moving anything over. Like, that's the beautiful part about this one. All you got to do is grab your calculator. Now, when you grab your calculator, again, once you turn it on, you're going to hit y equals. You're going to get rid of any garbage that's in there, and you're going to type in the equations. Now, this would be y1, so we're going to type 2x squared minus 2 in my graphing calculator. And then I'm going to go down and put this into y2, -2x plus 2. When you are typing, and I'm going to circle it in blue, when you're typing this, because it's in the front, make sure you're hitting the negative button and not the minus. Now when I hit graph, I forgot to change my window, but you're going to see a picture hopefully of something like this. I'll put the first one, the first one's coming in here like so, something like that. And the second one is doing something like that. Is that about what you guys see? Yeah, that's what I got for my picture. Now, again, what you want to do is you want to find out where these two spots, right here and right here, where they hit each other. That's what you're trying to find. In order to use the calculator to do that, does anybody remember how to use your calculator to do that? What do you push?
Second.
You push second, trace, and then if you scroll down to option number 5, that gives you the intersection. So I hit the button physically, second, the one that's in blue or yellow, depending on the age of your calculator, and the trace button. And I go down to option 5. And now, again, just to kind of walk you through it, I'll put it in orange so that you see it. Right now, the cursor is blinking right here, and it's asking you if you're on the first curve. Is that the first thing I typed in? Yes. So hit enter. Then it popped it up to here, and it says, is this the second curve or the second equation you typed in? If that is, you hit enter. And then it's going to keep it right there and ask you if you'd like to make a guess, which we don't want to guess, just tell us the answer. Hit enter, and again, it's going to go to the closest one possible. It happened to go to this one, even though my picture didn't look like it, it went to that one first. That ordered pair I got was at 1, 0. Then, to get the second dot, this one that's over here, I do the same process, but once I get to the first and second curve, I need to move the cursor closer to that intersection. So I'm going to hit second trace again, go option 5, but as soon as I do that, I'm going to move my arrow. I'm going to just use the left arrow cursor, and I put the thing right about here, just so that you guys know. I put it right on. That's close enough. Is that still the first curve? Yes. Hit enter. Is that the second curve? Yes. Hit enter. Do you want to make a guess? No. Tell me the answer. And I got -2, 6. Okay? So for that particular thing, then I have my 2 dots, and that's all we needed to do. So you have a problem like this, number 5 on your test tomorrow will ask you to solve by the system of equations by graphing. So you'll have to do that at least one time. Then 25, on number 25, I'm going to do it with substitution so that you see a second method. Okay. So for this one, I'm not going to use graphing. I'm going to use substitution, just so that you see both of them. So for this particular thing, what I'm going to do is I'm going to solve for y on one of the equations, or solve for one of the letters for one of the equations. Now, on the first equation, you have x squared and you have y squared. Don't use that. Pick the one that's easiest. And for me, the easiest one to solve is right here, that y's got. That's the easiest one I'm going to get by itself. How do I get rid of the 5? Divide. So I divide every piece by 5 in that part of the problem. What's -15x divided by 5? -3x. What's 5 divided by 5? 1. And 5 divided by 5 again is 1. So now, once I do that, I'm going to take this part of the problem and I'm going to stick it into the other equation for that letter. I'm using substitution. I'm physically subbing something in for something else. So I have x squared plus, parentheses, -3x plus 1 squared equals 4. Now, this is where a lot of people tend to mess this one up. because what they do is they try to square both parts, when in reality it should be something like this, plus negative 3x plus 1, negative 3x plus 1 equals 4. You have to...
Just to let you know, the seniors should be heading back to classes now.
Okay, it should be where you have to FOIL those two things. So what is negative 3x times negative 3x? 9x squared, good. What's negative 3x times 1? Negative 3x. What's 1 times negative 3x? Negative 3x. And 1 times 1 is? If I combine like terms, what's 1x squared plus 9x squared? 10x squared. What's negative 3x minus 3x? Negative 6x. And that's probably the one part that a lot of people mess up. Negative 3 is not 0. And that's what a lot of people think. Okay? If I go back 3 steps and back 3 steps more, I'm not at the starting spot. I'm back 6. Okay? Then if I'm going to subtract 4 to both sides to get it equal to 0, what is 1 minus 4? Huh? What? Negative 3. Now, the reason why I got it equal to 0 is because, remember, this is a quadratic, which means you can do one of about 5 different things right now. We can try to factor this. We can use the quadratic formula. You can use completing the square. You can use square root. Like, you can use all these different ones that we have off our scale that we have. Now, I will tell you this. I don't think it factors. Just by looking at the answers. Pretty sure it doesn't. So for this particular thing, then if it doesn't factor, what are you going to do? Use the quadratic formula? Okay, I'm going to use a new slide because I can't fit it all. All right? So what number was in the B spot? Plus or minus the square root of negative 6 squared minus 4 times, what number was in the A slot? 10. And what was in the C? All over 2 times 10. At the beginning, ooh, that's really hard to see, sorry. At the beginning, what's a negative and a negative make? Positive 6. Plus or minus the square root of, what's negative 6 squared? 36. What's negative 4 times 10 times negative 3? What's negative 4 times 10 times negative 3? Positive 120. Good. Over what's 2 times 10? 20. What's 36 plus 120? Now, from this particular thing, because we're trying to solve it on here, and if we did it by graphing and whatnot, it would be something that would not come out nice and pretty. Like, if you type in this part now, if you type parentheses 6 plus the square root of 156, close it, divided by 20, and then 6 minus the square root of 156 in parentheses, divided by 20, you're going to have both your x's. They do not come out as nice whole numbers this time. They come out as decimals. So when I type it in, notice how I put the parentheses in there? That's on purpose. Because if you don't, it's not going to divide it correctly. 6 plus the square root of 156. Close it, divided by 20. I got for the first one 0.92. And for the second one, I got negative 0.32. Those are the numbers I got for x. Those will be your x's. So once I have the x's, how do I get the y's? Okay, what I have to do then, I'm going to go back a slide for a second, as long as it'll go. There it is. Oh, too far. Okay, once I get it back into that, the red one right there, in order to get the y's, I got to plug both of those numbers in individually. And I'm going to put it in blue so you can see it. I would type -3 times 0.92 plus 1 to get one of the y's. And I would do -3 times -0.32 plus 1 to get the other y. And when I do the first one, when I put in the 0.92, it should come out to be a -1.77 or something close to it. And the other one should be 1.97. Not very user-friendly numbers. I know that, but that's why you have a quadratic formula, or you have a graph. If you would have graphed them, you would have found the same two ordered pairs. The ordered pairs you would have found would have been -0.32 and 1.97 would have been one ordered pair, and the other ordered pair would have been 0.92 and -1.77, which is the same thing that we got just by doing it with substitution. So on your test tomorrow, 5 and 6, 5 says solve by graphing, 6 says by substitution. So that's why I wanted you to do one. That's why I did one of each, so that you could see it. Now, I will tell you this. This one was kind of a little bit of work. It was a beast. All right? The one that we gave you, not as bad. Okay? Just so you know. But that's 25. 27. Has y is greater than x squared plus 8x plus 16. And the direction says graph the inequality. Number 7 on your test says graph the inequality. So this number 27 from your homework is the same thing as what number 7 would look like on your test. Now, these, if you remember, this was only one parabola, and you have to solid or dash the line, and then you have to shade parts. Would this be a solid or dashed parabola? Why would it be dashed? It doesn't have the equal to part. Now, how are you getting the shapes? Are you plugging in numbers? Are you finding the vertex? Or are you just sticking it in your calculator? All of them are okay options. I'm just wanting to know. How are you getting the shapes for these? Most of you are putting it in your calculator, aren't you? Okay, and that's perfectly fine. When you do this problem, you have to make sure that y is by itself. Is y by itself in this one?
Yep.
Yep. So I go to my calculator, and I go to y equals, and I get rid of the other garbage that was there from the first problem, and I type x squared plus 8x plus 16. And I graph it. And I get something that looks like this. That's what I get. Now, I dashed it on purpose because you told me it was supposed to be dashed, right? But that's where my parabola ended up. How do I know where I shade at? What do I do for that? Put in a number. Any ordered pair will do as long as it's not on the curve. What is the easiest ordered pair to use? 0, 0. 0 is greater than 0 squared plus 8 times 0 plus 16. What's 0 squared? 0. What's 8 times 0? 0. 0 plus 0 plus 16 is?
16.
Is 0 bigger than 16? No. The test point that I tested, I'll put it in purple so you can see it. The test point that I tested was right here. And that was a big old fat no. Was that on the inside of the parabola or the outside of the parabola?
Outside.
If it's outside and a no, then you have to shade where?
Inside.
On the inside. As a reminder, you want to shade everything that's true. Okay, that's how we do those. Okay, number 29 has y or x squared plus y is less than or equal to 7x minus 12. First of all, is the y by itself? No. How do I get the y by itself? Subtract x squared. Once I do that, now I can stick it in my graphing calculator. Reminder, circling it in blue, when it's in the front like that, in order so it's not an error, you have to hit the negative button that's down by the dot or the enter button. Okay? So I go into y equals, I clear out the garbage, I hit negative x squared plus 7x minus 12. And I hit graph. Solid or dash parabola do I need to write? Why? Okay, has that equal to part? And it does something like that, right? What ordered pair can you use to test it?
0,
0,
0.
0. I'll put that, I'll mark it in purple so you can see it. Is that inside or outside the bowl?
Outside.
Outside, good. So if I put 0, 0 in there, do you want me to put 0, 0 in the original problem or the one that we moved the x squared over?
Move the x squared.
Does it matter? No. So 0 is less than or equal to negative 0 squared plus 7 times 0 minus 12. What's 0 squared? 0. What's 7 times 0?
0.
What's 0 plus 0 minus 12?
Negative 12.
Is 0 less than or equal to negative 12?
No.
No. Where was the dot at? Inside or outside to begin with? Outside, and you said no. So where should I shade? On the inside. That's number 29. Hey, 31 has 2x squared minus x is greater than or equal to 5 minus y, and 0.5x squared is greater than y minus 2x minus 1. And it says graph the system of inequalities. What's the difference between the last two and this one?
Equation.
There's two of them, not one of them. Number 8 on your test tomorrow says graph a system of quadratic inequalities. This is just like number 8. Okay? Where you have 2. Do you remember when we did this one when we had 2? What was so special about when you had 2 of them? What did you have to do?
You have to shade them.
You had to shade the part that they shared in common. Okay? So, again, none of these equations right now are set up and ready to go. What do I need to do in order to get them ready to go?
Y is given.
Got to get y by itself. On the first one, how do I do that, Cameron?
Add 5.
Nice. So 2x squared minus x plus 5. How do I do it on the second one? How do I do? So add 2x and add 1. So I get 0.5 x squared plus 2x plus 1. As long as you get y by itself, does it matter which side you move it to? No. Then from here, I'm going to grab my calculator and I'm going to type them in. 2x squared minus x plus 5 into y1, and 0.5x squared plus 2x plus 1 into y2. Graph. By the way, are they supposed to be solid or dashed?
One is solid, one is dashed.
Which one's solid?
The left.
The first one. The first one comes in here and does something like that. The second one you said should be dashed? Is that what you guys see? Something like that? Okay. Now, can I use 0, 0 for the test points? Yep, and my red one is a little off, just so you know. I gotta change that red one a little bit. It comes in there. It doesn't go so deep. 0, 0 is on the outside of it. For the blue one, if I put 0, 0 in there, and if I'm gonna put it back in the original problem, 2 times 0 squared minus 0 is greater than or equal to 0 minus 5. What's 0 squared? What's 2 times 0?
0.
What's 0 minus 0?
0.
Is 0 bigger than or equal to, what's 0 minus 5?
Negative 5.
Is 0 bigger than or equal to negative 5?
Yeah.
So for the blue one, I have to shade this way, because it was true out there, right? The red one. Point 0.5 squared is greater than 0 minus 2 times 0 minus 1. 0 squared is times 0.5. Still 0. What's negative 2 times 0? What's 0 minus 0 minus 1? Is 0 bigger than or equal to negative 1? Yes. And again, that was on the outside of it, and it was yes. So then again, remember, I'm shading everything that's on the outside, and now I go back and I darken in the spot that they shared in common. Where did they share in common? Or was it both black and red, or blue and red? The outside. All right. So if I darken it in, it should be everything on the outside of it. Right? Okay. Again, you have one of those on your test tomorrow. That's just like number 8. Then 33. How are we doing for time? We got 5? Yeah.
No. Yeah.
Oops. 3x squared plus 3x minus 60 is greater than or equal to 0. The directions for 33 say solve the inequality. The directions for number 9 say solve using any method. show work for the method chosen. So here's what it means. It doesn't matter to me which way you solve this. If you solve it algebraically or if you solve it graphically. It's your choice. So I don't think I'm going to have time to do both. But if I did it graphically, because that's probably the one that most people are going to gravitate to anyway. You stick this into y1. So this is y1. And that's y2. So when I put that into y1, I have 3x squared plus 3x minus 60, and then 0. And I get a picture that goes off my screen a little bit. So this is actually pretty good. It goes like this. It comes like that. That's what I see on my screen. And then I also, because I'm using a color screen calculator, also have this red line that goes right here because that's the y2. Now, what it's asking you for again is it's asking you for when is the parabola higher than the line, than the second one. When is the parabola higher than it? Physically, it's on top of it here, and it's on top of it there. That's when it's on top of it. What you need to do is you need to identify these two ordered pairs that are right here so that you can tell me which way it goes. How do I find that number? How do I find those intersection points? Second trace, option 5. First curve, yep. Second curve, yep. Guess, nope. Just tell me the answer. And this one over here was 4. Second trace, option 5. Scroll it over. Get it closer to the other one. Second curve, guess, nope. Tell me the answer. And I got -5. So how you write the answer for this, though, is x is less than or equal to -5, or x is greater than or equal to +4. That's how you would write the answer if it goes up. If it would have been in between, so if it would have said less than. If it would have said less than, then you put the x in the middle, and you put the 2 on the other sides like that, like in purple. Now, I didn't have a chance to do 35, but just so that you guys do know, I did record this whole thing. So I will be posting that in Classroom in case you missed part of it. Okay? Don't forget to make a note card tonight so that you can use it. And oh, by the way,